Example number 7, part A, asks us to compute the derivative of f with respect to s if f of s is equal to this product. Now here's the thing, we don't actually have a rule for products yet. Okay, so if you took this, if you took f of s, oops, that's a bad f, if you took f of s to be equal to g of s times h of s, where g of s was equal to s squared plus 3 and h of s was equal to s to the third plus 2s plus 1, you cannot assume that f prime of s is equal to g prime of s times h prime of s. We've done it with addition in between, and if you had addition between these guys right here, that'd be good. You'd be ready to go. But we don't have anything yet. Okay, and it's actually not true for this. So what we need to do is we need to actually multiply or expand this guy out first. So f as a function of s is equal to, and when I multiply s squared in, I get s to the fifth plus 2s to the third plus s squared. And when I multiply 3 in, I get 3s to the third plus 6s plus 1. And if I combine like terms, I get s to the fifth plus 5s to the third plus s squared plus 6s plus, whoops, that's supposed to be 3. I forgot to bring my 3 in to this last term. Okay, so we have s to the fifth plus 5s to the third plus s squared plus 6x plus 6s plus 3. So that's f of s. Now the, oops, not f prime, just f. Get so used to writing that. So now we have to differentiate this. Now what I want to do is I'm going to call this guy y. I want to use the Leibniz notation. Now the book doesn't do that in this particular problem, but I think it's valuable so that you can see how that notation is working. So dy ds, because s is our variable over here, is dds of s to the fifth plus dds of 5s to the third plus dds of s squared plus dds of 6s, and lastly dds of the number 3. So this right here, let's pull all of our constants out. We can pull the 6 and the 5 out. So this would be dds still of s to the fifth plus 5 dds of s to the third plus dds of s squared plus 6 dds of just s and dds of 3. So this is 5s to the fourth plus 5 times 3 s squared plus 2s to the first plus 6s to the 0, 6 times 1 is 6, plus 0 here, because dds of 3, that guy is 0. So 5s to the fourth plus 15s squared plus 2s plus 6. So that's going to be our dy ds, or f prime of s. Okay, now let's look at b. B asks us to find the following. It wants us to find d dx of 10x to the third minus 8 over x plus 5 square roots of x. So again, we can think about distributing this operator in over these operations of subtraction and addition. So I'm going to write it like this. Now notice I'm using ddx, right? Because that's our variable here. Now I'm going to go ahead and pull out. Now we're going to make this minus. Okay, now we know using the power rule that this guy is 3x squared. We know from one of the previous sections that I think it was the section before this, like example 3 or 4, that the derivative of this is going to be negative 1 over x squared. Okay. And the derivative of this guy is going to be 1/2 times 1 over the square root of x. So this is going to be 30x squared plus, because it's negative times a negative, so plus 8 over x squared. And then this last one's going to be plus 5 over 2 square roots of x. And we can rewrite this guy if we want to, and this guy, so that they all come back up to the top. Like that if we would like to. And there's your solution.